Hi all. Last class we learned how to find the percent composition of a compound based on its chemical formula. This time we're going to approach it from a little bit different perspective, and then we're also going to look at some of the types of word problems that we can answer based on percent composition. So here's our first example problem. What is the percent composition of a compound that is found to contain 34.6 grams of oxygen? Well, let's try that again. 34.6 grams of oxygen and 87.0 grams of nitrogen. So the actual equation remains the same. So if I want to find the percent of oxygen, it's equal to the mass of oxygen divided by the total mass of the compound times 100. So plugging in numbers from this problem, we have 34.6 grams of oxygen divided by the total mass of the compound, which is 34.6 plus 87.0. And then we're going to multiply that times 100. And we end up with 28.5% oxygen. We subtract that from 100, and we're going to get our percent of nitrogen. It ends up being, let's try that again here. Calculator problem. So we have 71.5% nitrogen. That's all there is to it. The equation remains the same. Notice over here that I did the mass of the oxygen divided by the total mass of both of them together, and you've got to do that. All right, so these problems are really straightforward. Let's look at an example of a kind of word problem that you might have. All right, so here's our problem. What mass of hydrogen would you expect to recover if you decomposed, that means broke apart, 450 grams of water? So you decompose water by running an electric current through it, and that'll break it up into its hydrogen and oxygen. So the first thing that we need here is what is the percent composition of water in terms of hydrogen and oxygen. And we've done this before, so I'm not going to do it again, but the percent of hydrogen in H2O is about 11.1%, which means that the percent of oxygen is 88.9%. So we're going to use that percent composition and the percent composition equation to answer this question. So remember, the equation is the percent composition is the mass of the element divided by the mass of the compound times 100. And that's going to equal the percent composition. Okay, so we're basically going to plug stuff into this equation and solve for an unknown. So we take a look at our problem here. What mass of hydrogen? What mass of hydrogen? That is the mass of the element. That is our unknown. Would you expect to recover if you decomposed 450 grams of water? So 450 grams of water, that is the mass of the compound. And what is the percent composition? Well, our element here is hydrogen, so we are going to have to use the percent composition of hydrogen in our equation. All right, so let's plug in what we know. Let's go ahead and say that the mass of hydrogen, that's our unknown, mH, that's on the top of our fraction. The mass of the compound is given in the problem, 450 grams of water. We're going to multiply that times 100 in our equation, and that's going to equal the percent composition of hydrogen, since that's the unknown element. So we've got 11.1 is equal to the mass of hydrogen over 450 times 100. So we're solving for mH. We've got to get it by itself. So let's go ahead and get rid of the 450 by multiplying both sides by 450. Hey, look, it's algebra. Yay! So the 450 cancels over on the right-hand side. We still have to get rid of the 100 that is there, so we're going to divide both sides by 100. Divide both sides by 100. That gets rid of the 100 on the left-hand side. And notice the only thing left then is our variable, mass of the hydrogen. And mass of hydrogen is going to be given to us with this math right here. 11.1 times 450 divided by 100. And when we throw that into the calculator, we end up with 49.95 grams of hydrogen, and that's what we've solved for. So if we take a chunk of water, 450 grams of it, run an electric current strong enough to break the hydrogen and oxygen bonds, we can expect to recover 49.95 grams of hydrogen. Subtract that from 450, and hey, look, it looks like we can expect about 400 grams of oxygen as well. All right? Why might that be important? Well, in the future, if we can master nuclear fusion to provide power, hey, we could just take hydrogen from breaking apart water molecules, run them into each other, and make helium, giving off energy in the process. Our fuel, it would essentially be the hydrogen from water. Our waste product would be helium, a completely inert noble gas. No waste, free energy. It would be fantastic. We're probably still, I don't know, who knows, 100 years away from that. But it'll be pretty cool if it ever happens. All right, that's it. You've got your assignment. Get to work.